All right, day 13, section 6.2. We're going to focus mainly and exclusively on quadrilaterals today. So in 6.2, we have a specific type of quadrilateral, and we call it a parallelogram. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So opposite sides do not share a vertex. Opposite angles do not share a side. So now that we've established what a parallelogram is, we can say if a quadrilateral is indeed a parallelogram, then its opposite sides are congruent. So opposite sides, that means that BA is congruent to CD. AD is congruent to BC. All right, just following the same trend, we're going to define something before we are able to use it. Consecutive angles. They're angles of a polygon that share a side. So B and C are consecutive because they share that side. So B and C because they share this side. That means B and A are also consecutive angles. B and A are also consecutive angles. A and D are consecutive. D and C are consecutive. So every vertex has two consecutive angles. Theorem 6.4, if a quadrilateral is a parallelogram, here comes another property, then its consecutive angles are supplementary. That means B and C, if we add them up, they equal 180. That means A and D. That also means B and A. That also means C and D. Now, the way I wrote them, hopefully you noticed something here. B is matched up with A and C. D is matched up with A and C. A and D, D and C, B and A, B and C. And we'll come back to what hopefully you caught on to there. All right, this is hard to see. Let me kind of fill this in. You have O, P, R, S, and this is S is 64 degrees. What is the measure of angle P? Well, P is consecutive to S. So that means the measure of angle P plus the measure of angle S equals 180. And that's theorem 6.4. So the measure of angle P plus 64 equals 180. Now, most of you are just going to do that part right there, and that's fine. That's 116 degrees. Suppose you adjust the lamp so that S is 86 degrees. So again, that's just going to be 180 take away 86, because where is R located? Let's actually go back up here. R is also consecutive to S. So S and R should also be 180. So 94 degrees. All right, so theorem 6.5 is basically going to go ahead and put into place hopefully what you picked up on before, because each vertex has two consecutive angles, and it's supplementary to both of those. That means that if a quadrilateral is a parallelogram, then its opposite angles are congruent. Which hopefully that makes sense. If B and A add up to 180 and B and C add up to 180, well then A and C are both contributing the same amount of angle measure to B to make 180. So that means the measure of angle A is congruent to measure of angle C, and the measure of angle B is congruent to the measure of angle D. Actually, since we're using congruent symbols, we really don't need the measures on there. Just being a little picky there. All right, theorem 6.6. If a parallelogram is if a quadrilateral is a parallelogram, then its diagonals bisect each other. So they intersect, but they intersect so that they bisect. So AC, BD, let's say they intersect there at E. That means that BE is congruent to ED, and then AE is congruent to EC. All right, so this is going to lead us to some algebra problems, and the algebra problems are going to be a little bit more involved than they have been. So we have this parallelogram here. We have y plus 10. We have x. We have 2x minus 8. And we have y plus 2. Congruent? Congruent. So that means y plus 10 is going to equal 2x minus 8. Now, we cannot solve that because we have two different variables that are involved. If we set up the other bisected diagonal, again, we have two variables that are involved. X equals y plus 2. Now, this one is much nicer because on the left-hand side, we have just x. So if this is what x equals, we can take that and plug it in for x over here, which gives us y plus 10 equals 2 times x. I'm going to remove that. And instead of x, I'm going to put in y plus 2. Now I have an equation with just y values. So that's 2y plus 4 minus 8. Let's keep cleaning this up a little bit. Y plus 10 equals 2y minus 4. I'm going to do this in one step. I'm going to subtract the y to the other side, and I'm going to add the 4 to the other side. So that cancels out, and that cancels out. That's 14 equals y. If 14 equals y, we know x equals 14 plus 2. X equals 16. It says, what are Km and Lm? So Km equals y plus 10. Now you can just figure out what that is and double it, since this is the same side, or just keep going, plus 2x minus 8. So this is going to be 14 plus 10 plus 2 times 16 minus 8. So Km equals 48. And then Ln, let's show you how the other way would be if we did not write it all out. Ln is going to be x plus y plus 2, or we can just double whatever this is. Let's try it that way. X was 14. Nope, x was 16. Which is 32. So there's a pretty involved problem there. I would definitely go ahead and pause it here, see if you can try this one on your own. Make sure you guys can see this. This is 2x. That's y. This is going to be x plus 1, 3y minus 7. So go ahead and pause it and see if you can get the right answer. So y equals x plus 1 and 3y minus 7 equals 2x. If y equals x plus 1, I'm going to plug that in for y. We're going to distribute that. 3x plus 3 minus 7 equals 2x. I'm going to subtract 2x from that side. Combine these and then bring them over. X equals 4. And that means y equals 4 plus 1. So y equals 5. That means that PR equals, so PR involves one of the sides that's 2x. And I'm just going to double that. So PR equals 4 times 4, which is 16. X SQ is going to be double that y side. Or you can do y plus x plus 1, that's fine. So 16 and 10. All right, theorem 6, 7. Last theorem here, nice and easy as well. If 3 or more parallel lines cut off congruent segments, so if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if these three lines are parallel, and what this says here is if AC is congruent to CE, right here. Oops, there we go. So if that transversal is going to go through those three parallel lines and create congruent segments, then it's going to do the same thing with any other transversal that passes through. Because if they're all parallel, that means that they're not going to be tapering towards each other. So this distance is always going to remain the same. So BD is congruent to DF. All right, so if these three lines are parallel, actually four lines, and AB equals BC, which equals CD, which is 2. What that tells us then is that these are all going to be congruent as well. Not to the green ones, but to each other. So if EF is 2.25, that means they are all 2.25. I'm sorry, this is EH. So EH is the entire thing. So 6.75. And the last one, all four lines are parallel. EF is congruent to FG and GH, and they're all 6. We actually don't care when they tell us that they're 6, but that's basically them telling us that they're all congruent. They could just put in those dashes. AD is 15, so this time they told us they're all 15, but we know that they're all congruent. That means they are each going to be 5. So CD equals 5. All right, make sure you guys check out that homework, especially that algebraic one that's solving a system of 2 equations. If you guys are working together, if you're relying on another classmate, maybe an older brother, make sure you guys are able to do that on your own. Email me, contact me, come to the office hours with any questions. Make sure you guys are keeping up with all of this and you're being responsible with staying in contact with me, even if you have to contact me to set up a special one-on-one time outside of my office hours. I am available throughout the day for you guys to do that. All right.